Okay, welcome to the Ags3 Module 1 study guide video. On page 1, they're all pretty similar, so I'm just going to choose a few to do and go from there. So 1's pretty easy, as is 2, so I'm going to go ahead and start on 3. So find the inverse of each equation below. Once your group has completed all questions and agreed upon answers, call your teacher over for instructions on part 2. Okay, we're not doing that, but I do want you to compare answers with your group today. So for number 3, we need to find the inverse of the r of x function. So when I begin these, I start like this, because I know that I have to switch x and y, and that r of x and y are the same thing. And then I'm going to add 7 to both sides. And then I'm going to take the square root of both sides. Remember, the square root goes over everything. And then I'm going to take away 3. There it is. So that is kind of how number 3 is going to work. And we've done the inverse. And then just keep in mind, everything that we know about inverses. They reflect over the line y is equal to x. And if we plug one into the other one, then we will be left just with x. Okay. Let's do, that's pretty easy. I'll just go ahead and do 5 while I'm here. Okay, so for 5, I'm going to do the same thing. Y is equal to square root of x minus 10, and then the plus 3 is out here. So I'm going to I'm going to subtract 3. Then I'm going to square both sides. Okay, remember at this point, do not do this, okay? This does not make any sense, because remember y minus 3 squared is that, and that'll actually become important later. All right, and then from here, we are going to add 10. So we're going to have y minus 3 squared plus 10 is equal to, oh, I forgot to switch x and y, but that actually serves as a good example. So I need to switch x and y, and I need to switch x and y. So we got to be real thorough with showing our work on this one. And then I need to switch again, and then again. And then here is our answer. Okay, let's do 7. So 7 is y is equal to 3 to the x. So if I switch x and y, it'd be x is equal to 3 to the y. And I'm going to turn this into a logarithm. So I'm going to have log of my base number 3. And then we don't know what that is going to equal, so that's going to be our x. And remember, when you do this, you get the exponent. So there is the inverse for us there. So on all of these, we could be writing f of negative 1 of x is equal to, and that just shows function. So we should probably be thorough in doing that on all of them, and you can do it on all the other ones that you do today. Okay, there we go. Okay, we are on to the next page. Okay, so for this one, we need to represent each function and its inverses in all forms listed below. All right, so the table of the regular function, I'm going to plug in negative 2. I think you guys know how to do this, so I'm not going to explain it too much. And then I'm going to get this and this and this, and this. So the inverse then, I don't even need to do math really for the inverse because I know that it's just this table switched. Okay, so we have now done the table. Now we have to do the graph. Represent each function and its inverse in all forms listed below. Okay, so for this one, the graph of the original is going to be -2, -7, which is like down there, and -1, -4, 0, -1, 1, 2, and 2, 5. And then the inverse is going to be in red, so I'll do those in this color. -4, -1. Oh, I gotta go one more over. Okay, and just as a review, remember these reflect over this line right there, which we can see that it does. Okay, let's do the domain of the regular function. So the domain of the regular function, what can I plug in for x? I can plug in anything for x. So I'm going to have -infinity to infinity. Shouldn't be equals. And remember, we use a parenthesis because we never get to -infinity. So make sure that you put a parenthesis if you mean a parenthesis and a bracket if you mean a bracket. Okay, bracket is included, parenthesis is excluded. So what are our range values? What are our range values? It's the same thing. Could be anything and anything. So we know that in the inverse, the domain and range are switched, and so since in this case they're the same, it's all just -infinity to infinity for this problem. Okay, now we need to solve for the inverse. So remember I have this, and then I'm going to switch x and y, and then I'm going to add 1, and then divide by 3. So that's going to give me, I kind of botched that up there, so I'm going to rewrite it, is equal to x plus 1 over 3. Okay, show your algebraic work to determine